differentiation. Okay, remember differentiation, just to recap, what you're actually doing is you're taking a function and you're deriving a derivative, and the derivative can be utilized to help you with certain calculations. Okay, so that's what we haven't discussed yet. All you know now is how to find the derivative. Right, so that was the first part. Alright, the last bit here is just application. So when do we use the derivative? How do we use the derivative? That's something that we still need to discuss. Okay, so you can write a heading. You can say applications of the derivative. Right, because last time we spoke about how to get the derivative and how to use that general equation. Now we need to know how do we actually use the derivative. So what can it be used for? That's the last bit in this section. And then they change focus to integration, okay, which is actually similar to differentiation. Okay, we'll discuss that later.
Application of derivatives or differentiation? Application
of derivatives or differentiation, both is fine. Either or. The derivative is just what you get from the differentiation process. Okay, so yeah, it's calculus. It's something that we use to help with certain.
Did you do calculus last one?
Well, calculus is just the like main topic, and then you get different sections. Yeah, so this falls under that section. Okay, calculus is just the name that's used when derivatives are applied practically. Okay, so you didn't do derivatives as far as I know last year, because if you did, you would have recognized the steps this year. Okay, but so yeah, but you still looked at algebra, you still looked at solving for x, that type of thing. Okay, so calculus is just the fancy term that groups different like areas of mathematics together. That's all. Okay, so calculus is kind of like applied mathematics in a way. Okay, so where we take formulas and functions and we actually use them to solve like problems in a way. Okay, right. So bullet number one, you can or label it number one: tangents and normals. We'll describe what they are. Okay, you should have an idea what a tangent is because we spoke about that last time. But we'll mention it again. And normals. Okay, normal, and then just with an S at the end, normals. Right, so underneath the word tangent, you can say a straight line.
That touches a circle.
Yes, okay, that touches a curve. Okay, it doesn't have to be a circle, it's just a curved line. Alright, so a tangent is just like the gradient or the slope of a curve. Remember we drew that picture last time? And we had a semicircle and then we drew different tangents on it. Okay, so you can refer back to that note. Okay, that's all it is. Right, a normal is a line perpendicular to the tangent. That's what a normal is. Okay, so normal is a line perpendicular to a tangent. Okay, so for the normal, you need to remember gradient of the one line, so M1. Just make a note, brackets. Okay. Yeah, then make a note, brackets. M1 times, yes, four normals. M1 times M2 equals -1. Okay, remember, if you have a perpendicular line, the one gradient times the other gradient will give you -1. Okay, that's how we find it. Correct, yeah, that's what we looked at previously related to what? Straight lines. Okay, so you have one line that does this, and it has a slope. And then if you want the perpendicular line, you've got to find the multiple. Okay, so the one multiplied by the other gives you a -1. Right, so here's an example, and I'll show you how to use the derivative. So what are we going to be using the derivative for? First application is to find a tangent and a normal. Okay, so a tangent is what? A line that touches a curve. Okay, it could be a circle, it could be anything. Right, so the first example you can say e.g.
For tangent.
Yeah, no, well, for both actually. Yeah, so there's one example covering both.
Okay.
You need an equation. So the equation is y equals 3x squared minus 7x plus 5. Okay, so that's the formula. What does that formula represent? What type of graph is that?
Parabola.
Correct. Okay, so is the parabola happy or sad?
Happy.
Happy, because the number in front of x squared is a positive 3. Okay, so if it's a positive 3, it is going to be sloping in that direction. Okay, good. So you know that this is a parabola. Okay, you know that there are rules that link to a parabola. So you can use that ax squared plus bx plus c. Okay, you know how to find the turning point of a parabola. Those are all things we've used before.
Yeah.
Okay, but now we're not going to use that because that's separate, okay, to this in terms of differentiation, okay, derivatives. So is it possible to find the gradient of a curve using the derivative? Yes. Okay, what we do is we make the derivative equal 0. Okay, and we actually find the slope. Okay, well, the derivative equals 0 is actually the turning point. Okay, so underneath this you can just put a note. These are separate notes relating to this example. Okay, so number 1 you can say derivative equals 0. This is additional to what we've got here. Okay, derivative equals 0. Finds the turning point. Okay, so let's show that. Let's first use what we know. Okay, so how do you normally find the turning point? X equals minus b over 2a. Remember that. Okay, so let's write that down. X equals?
What are we using that? Tangents and normals?
No, this is for what we just wrote down. So
turning points, you want to say?
X equals minus b over 2a. Okay, so let's substitute. What is b?
B. Let me just write the normal formula, yes. What is the normal for AB?
Ax squared
Ax squared
plus bx plus c.
Okay, so B is minus 7.
Minus 7, yes. So x equals minus, open brackets, minus 7.
Yeah. Minus 7.
Over what?
2a is
correct. So that would be plus 7 over 6. Okay, don't write TP because it's the x value of the TP.
Oh, yeah.
Okay, so to get the turning point, you still need to work out y. Okay, so you're just working out one coordinate of the turning point. Okay, so it's 7 over 6. Right, if you wanted y, how would you get y? Substitute back into the equation. Okay, we don't have to show that. That's not something we need to do. Okay, but that's just the one thing. So now, do you agree the turning point gives us the x coordinate of the turning point? Right. So now, can I use the derivative to find the turning point? Yes. So on the left, underneath the word derivative equals 0, what is the derivative? So dy over dx is what?
dy over dx.
So derive the derivative from your y equals 3x squared minus 7x. You still remember how to find a derivative?
Yeah.
The exponent times the number in the front.
Let me just write the formula down. It's easy, but I just need the formula.
Okay. You can look at the formula if you want to. You don't have to always write down the formula every time, but you can now because you obviously because you're obviously learning. But generally, you can just write down what the derivative is.
-1. Okay, so dy over dx equals 2.
Okay, so 3x squared.
So 3x squared.
What do you do there? Take the 2
times 3.
So 6. Then
6x.
2 minus 1.
2 minus 1.
Okay, then what's the other term? Minus 7x. Okay, so what do you do when you have an x on its own?
Nothing.
You just drop the x,
Okay.
and then you'll have minus 7. That's the derivative. Okay, what happens to constants? What happens to plus 5? Yeah, there is no derivative for a constant. Okay. Okay, so the constant is obviously 5. There is no derivative for that. So that is the derivative. What is the derivative? 6x minus 7. That's the derivative. Okay, so what did we say earlier? To find the turning point, we can do what? Make the derivative equal 0. Okay, so now make the dy over dx 0. So on the next step, 0 equals 6x minus 7. Solve for x.
Okay, so now this is to find the turning point.
It's exactly the same. Yeah. It's just you find the same answer, but you use a different equation.
So 0 minus 7 plus 7 equals 6x. 7 equals 6x.
Correct.
6.
Correct. So 7 over 6 is x. Is that the same as what we got previously?
Yeah.
Right. And those two answers have to be the same because the x value of the turning point is 7 over 6.
Yeah.
We cannot change that. Right. So that's something to consider. Right, so now you know that the derivative can be used to find a slope. Well, we can find a slope if I know what the actual point is. So we need to know a point on the actual graph. So now we can use something different here in terms of continuing with this example. Okay, just another application. Okay, so that's the first thing. You can find a turning point. Yes, you. Okay. Right, so that was the first part. This is still following the same example, just a different application. So you can maybe bullet it and then label it something else. Okay.
So these are the uses of derivatives, basically.
Yes. Okay. So
okay. Sorry, can I go get a tissue?
yeah, of course. Yeah, don't stress. Shame.
Okay.
Alright, so the heading for this one, in terms of application, you can bullet it. Finding the gradient of a tangent. That's the focus. Right, so we know this is a parabola. We can find the gradient of a tangent at any point along the parabola. So finding the gradient, maybe even say and equation. So there's two things that they've done here, but we'll put it as one. Yeah, so it's the gradient and the equation of the tangent. The equation has a T-I-O-N. Yeah, okay, but it's the equation of the tangent. Okay, that's it. Right, so let's find the gradient of the tangent. Let's start. There's two parts. Part 1, get the gradient. Part 2, get the equation. But they both look at the tangents. Okay, so first thing we need to do is find the derivative, obviously. Okay, because everything here is looking at differentiation.
Okay.
Right, so you can write down what you wrote down previously. dy over dx equals 6x minus 7. Okay, you can either show the working again if you want to, or you can just show the answer, up to you, and then just see before or see previous calculation.
So is that just write
the derivative?
6x plus minus 7.
Yes. Okay, 6x minus 7 is the derivative, which is the dy over dx.
Let me just write the formula on top here, actually. So y equals 3x squared minus 7x.
Okay, so do you agree that is a parabola and there are many points on the parabola? Right? So now if I'm looking at a tangent, do you agree the tangent could be anywhere along that parabola? Okay, you drew a little sketch earlier, that little happy face or smiling face.
Yeah.
Okay, so you could have a tangent anywhere along that line. Okay, remember we drew some tangents. So now they need to give you a specific point. So here they said, find the equation of a tangent at point x equals 2. Right, so next to that equation you wrote at the top, just add when x equals 2. When x equals 2. Right, so when x equals 2, we're going to find the tangent. We're going to find the gradient and the equation and all that. So that they must give you, because as I said, there are many points along the tangent. We need to know where are we on the actual tangent.
Okay.
Okay, so we are at point number 2. Right, so how do we find the gradient? We need to substitute the 2 which is the point that we're looking at, into the gradient. So you can put a note there. Asterisk. To get the gradient, we substitute the value of x into the derivative. That's what we're doing.
So you get
the gradient. We substitute the point into the derivative. Yeah, so what point are we looking at? We're looking at when x equals 2. Do you agree? Okay, they have to tell you where you are in terms of the graph.
Okay.
Okay, so I'm where? At x equals 2. So let's put 2 into the derivative. What do you get if you put 2 into the derivative?
How do you put it in there?
Substitute.
Oh, okay.
Okay, x is 2, so substitute 2 into x.
Was this whole equation?
Yes, so
or just, yeah.
dy over dx equals 6 brackets 2 minus 7. What does that give you?
It's 12 minus 7. 12 minus 7. It's 5 of them.
Yeah.
Yeah.
Okay. Right, what does that 5 represent? The gradient, exactly. Okay, so you can circle that, label it. That's the gradient.
What is the gradient when x is equal to 2? Okay.
Yes.
Okay.
So now how do I find an equation of a straight line? What is the equation of a straight line?
Y plus mx plus c.
Okay, good. So the next part is obviously to find that equation. Right, what do I need to get the equation? I need 2 things. The gradient and a point. Do I have the gradient?
Yeah.
Yes. Do I have a point?
Yeah, 2.
Well, I have half a point. So to get a point, I need the x and the y. So how do I get a y?
Okay, so what are we doing now? Finding the equation.
The equation, yeah. So y equals mx plus c.
Now find the equation.
Yeah, y equals mx plus c.
Okay.
Okay, so what do I need in order to get that equation? I need 2 things. I need the gradient and I need a point. Do I have a gradient?
Yeah.
Yes. Do I have a point?
In half.
I have half a point. So I've got an x, I'm missing a y. So how do I get a y if I have an x?
Make x 0 and make y 0.
No, if you make x 0 and y 0, you're finding intercepts.
Okay.
You don't want to do that. Okay, you want to know what is the corresponding y for that x.
Okay.
So you plug that into the equation.
Okay.
Okay, because the equation gives you a y. So write down the equation y equals 3x squared.
Gradient is 5. Okay.
Yeah, that was what we calculated.
Yeah. Need to find the point.
Yeah, so a point has 2 coordinates. A point has an x and a y. Do you have an x? Yes. Do you need a y? Yes. Okay, so we know from algebra, if you have an equation with y and x, I can substitute the one to get the other. So y equals, no. That's the equation. We need the point, yeah. So we're trying to find y equals mx plus c. Okay, so y equals 3x squared minus 7x plus 5.
But this is a parabola, so why are we trying to find the straight line?
We're trying to find the point where, so yes, this is a parabola, but that parabola has an x value and a y value.
Yeah.
So draw a little sketch, get a pencil there. Okay. Alright, so you've got this. You've got a parabola that does this. Okay? That's a happy face. Okay, you're looking at it in the right direction. Right, you've got this, a tangent that touches
So find the
x
equation of the tangent.
equals 2. That's what you've got. Okay, so you know that at that point, that is x equals 2. You don't know what the y is.
So we're basically trying to find the straight line of the tangent.
Yes.
Okay.
Okay, so the only reason why you're substituting the x into that equation is because you want a y. There is no equation for the straight line yet.
Okay, cool.
Okay, so let's find the y by substituting the x in.
Let's find the y by substituting the y within this equation.
Yes, because that's the equation that you know.
Equals 3, 2. What do it mean? 7. 3. So
3 is correct, good.
X is
So now you know the coordinates, 2 and 3, good. Okay, so now can you find the equation of a straight line? Yes, and this is revision of y equals mx plus c. Okay, so now use that, use the gradient and use that point 2 and 3 and get an expression y equals mx plus c. That's the last part.
Equation. Not tangent.
Yeah, that's right.
Okay. So y equals 3 equals 5 2 plus c.
Good. Okay.
So
Find c first.
equals 10 plus c. 3 minus 10 equals c. 7 minus 7 equals c.
Correct.
No.
You're finding c, you got it. Alright, so now just write down the equation for the tangent.
Okay, so therefore,
Remember equation with the t.
no.
Okay. It sounds like an S, so don't worry. It happens, yeah. Okay. T-I-O-N. Okay, good.
Equation
Of the tangent, or for the tangent, yeah.
Equals to.
Okay, so equals to what? You've got everything?
Yeah, so it's y
Good.
equals to.
What's the m?
M is 5.
Yes.
5x.
Yes. What's the c?
Plus
Minus, yeah. Minus 7. And then you got it. Right, so that's how you do it. That's the process. Okay, so a derivative helps you to find the gradient, and by knowing what the gradient is, we can then substitute and do some maths to get the tangent. Okay, so we're just trying to get a tangent, basically. A tangent to a point on the graph. Right, just below that, you can just make a note. If we wanted the normal, how do we find the normal? We use that m1 times m2 equals minus 1. Okay, so just add that point there at the bottom. At the bottom there, just put a note, just like a side note. Okay, so do you agree you've got the equation of a tangent? Okay, what is a normal? It's a line that's perpendicular to a tangent. So just a side note. We have the tangent. We can find the normal if we use m1 times m2 equals minus 1. Okay, it's just a separate side. We have the tangent. Okay, you have the tangent. You've got it. There's it there. Y equals 5x minus 7. So is it possible to find a line perpendicular to the tangent? Yes, by using that m1 times m2 equals minus 1.
No, find normal.
Well, you don't have to find the normal. It just depends on the question.
Yeah,
okay,
no,
you can find the normal.
Which is perpendicular.
Yeah, perpendicular to that equation.
And we do that by m1 times m2.
Yeah, you use that m1 times m2 equals minus 1. Okay, because that gives you the gradient of the normal. Okay. Alright, so that covers that bit. Now we need to change focus. So now we've got another application of derivatives. That was the first. The first was tangents and normals.
Okay, are we not going to do this part?
No, that you don't have to worry about, yeah. Okay. Right, we made a note of it, so let's look at the next bits. Okay, number 2. Right, so second application. That was number 1, tangents and normals. Number 2, increasing and decreasing functions.
Okay.
That's the first one. Well, the second one actually. Increasing and decreasing functions. Right, this is another application. So here you need to draw a little sketch like this. Just draw a, you don't need to put any points on it, but you need to draw a parabola. Okay, so just draw a parabola. Maybe you can use that. Right, so just draw a parabola. Right, so there's the parabola. Right, so what's special about a parabola? It's a curve. Do you agree? So there will be tangents that are increasing and then tangents that are decreasing. It's kind of what we spoke about on Wednesday, where we looked at a semicircle. Okay, and I drew little tangents to the actual graph. Right, so if you had to draw tangents on that graph, where would the tangents be negative in terms of gradients? When it's sloping down.
Yeah.
Do you agree? So if you look at the left, alright, so let me use this again. If I look at the left, which is this side, is this tangent sloping upwards or downwards? It's sloping down, yes. Okay, so if I look at it this way, sloping down.
Okay.
Right, so then this will keep sloping down until some point where it'll be flat. Okay, and then what happens? It starts sloping up and up and up. Does that make sense? So now on this side, you're going to write down m equals, or m less than 0, rather do that. Okay, m less than 0 meaning m is negative. Okay, on this side, m is greater than 0, m is positive. And then here at the turning point, m equals 0, which is flat. Okay, so that's what we need to sketch. Right, that's what we need to sketch. Okay, just to show the increasing and decreasing functions, because here they're using that knowledge to identify where is something positive and where is something negative, i.e. where is it increasing, where is it decreasing. Okay, and it has to do with the tangent, that's the key. Okay, so we're looking at tangent, we're looking at lines that are touching that particular graph. Okay.
Okay.
Right. Are you going to know that that relates to tangents? Or do you want to sketch some tangents?
That's okay. I'll say yeah.
Okay, yeah, because you wrote down the m's and that, but maybe just make a note that that relates specifically to the tangents. Right, so here's an example. F of x equals x to the power 3 minus x squared minus x plus 7. That's the function.
Minus x plus 7.
Plus 7.
Okay.
Right, so do you agree that's a function?
Yeah.
A function can be drawn on a graph and it would look in a specific shape. Okay, so now if I'm looking at the increasing and decreasing functions, the instructions here were to find values of x where that function is increasing. So you can put instructions here. You can just say, find values of x where the function is increasing. That's the instructions. Find values for x.
Yeah.
When the function is increasing. Right, so how do we do this? We need the derivative. So step number 1, get the derivative.
So find values for x when the function is increasing. What do you mean by function increasing?
Increasing?
Like going up.
Or down, yes. Okay, exactly. So it's basically like a rate of change almost.
So first one, get derivative.
Yes. Okay, so derive the function. In order to get the derivative, what would we have? Okay, so apply your derivative rule. So now this will be f dashed x.
Yeah.
F dashed x equals what?
So
You do that.
Dashed x equals. So x 3 minus 1 is 2, so x squared.
Now what do you do to the 3? The exponent.
So times by there, so it's 3x.
Yes.
So it's 3x. X minus 1 is 2.
Yes.
Minus 2x. So 1, so it's 1.
Yes.
And then you have nothing happens.
No, you have minus x, so you drop the x, so you're left with the minus 1.
Minus 1.
Okay. The constants don't have a derivative. There's the derivative. 3x squared minus 2x minus 1. Okay, constants don't have a derivative. That's what we said earlier. Okay. Just for a recap. Right, so what do we know is happening to the derivative? Increasing or decreasing?
Pardon?
What do we know is happening to the derivative? Because the derivative gives you the gradient of the tangent against the function. So do they want us to find x's when it's increasing or decreasing? Increasing. Right, so if I'm looking at the tangent increasing, is the tangent going to be this greater than 1, less than 1, or equal to 0?
Greater than 1.
Exactly. So make that derivative greater than 0. Okay, so derivative greater than 0.
How do you do that?
So show that. Next line. 3x squared minus 2x minus 1
Yeah.
greater than 0.
Okay.
And then solve for x. Let's see if you still remember how to do this. This is some revision from last year when you had inequalities. Yes, so now that's an inequality. Can you find values of x for that inequality?
Okay.
Okay, this is algebra from last year. Be careful. It's a trinomial. 3 terms with x squared, x, and 1.
Okay.
So if it's a trinomial, what are you going to do? Factorize. You need to factorize the trinomial. Okay, so can you factorize the trinomial? Can you change that 3x squared minus 2x minus 1 into 2 brackets?
No.
Let's see.
So take out 1x. Okay.
Yeah, we'll factorize. Do it the way you want to do it. No, you can't take out an x. Because it's 3x squared minus 2x minus 1. Okay, the minus 1 doesn't have an x. So it's just 2 brackets. Yeah, so it's basically like first and last, that type of thing.
Okay, so 3x and then x. That's 1 minus 1.
Yes, but you need to know where's the plus 1, where's the minus 1, which side. Does that work out?
Plus 1 times minus 1 is minus 1, so that's fine. But it must times to equal that, eh?
Yeah, well, the inners and outers that are multiplied needs to give you the middle term.
Okay. So, okay, so it's not that.
So inners?
Plus 1 times minus 2. Minus 2.
No, that's right.
Minus 2.
No, there's no minus 2 there. Because negative and a positive 1 gives you a negative 1. Okay, so what's the outers? Multiply the outers.
Plus 1.
Multiply the outers. What's the outers?
So plus 1.
First and the last.
Minus 1 is minus 1.
Yeah, but
so
now.
It's not minus 2.
Okay, but see, we're trying to get the middle term. So what is the first and the last? First minus last. 3x. 3x.
First minus last.
Times. Okay, first. Okay, so FOIL it.
Yeah, no, I'm just saying with a trinomial, how do you get the middle term? You have to times these two, hey, to get that, and plus n to get that.
Yeah, that's what I'm saying. So to get the middle term, it's the outers and the inners. So what is 3x times minus 1?
Minus 3x.
Exactly. What's the inners? What's 1 times x?
1x.
Good. What is minus 3x plus 1x?
Minus 2.
Exactly. So that does work. Okay, see, it's outers and inners that give you the middle points. Okay, yeah, so that's a bit of revision. I think if I can find some of those trinomials, it's a good idea to practice some of that, because I can see a little bit rusty with it. So let's see if there's anything here. I'll check for it just now. Okay, so carry on. Find x. What is x going to equal?
Minus 1 over 3 or what?
Okay, so you've got values for x, minus 1 over 3 and 1. Good, but we need to do the test. Okay, why? This is a inequality. So with inequalities, we need to draw a number line. Okay, so let's draw a number line. Draw a number line and put those points on the number line. Okay, so we draw a number line and then we write down negative 1 over 3 and then put another point, 1. And we need to test. That's how we do the solving for the inequalities. Okay.
Okay.
Alright, so now we need a test. What number is smaller than minus 1 over 3?
Minus 1 over 4.
Yes, but that's going to be difficult to substitute. Do you really want to put in negative a quarter in? No, so take an easy number. Minus 1 is smaller than minus 1 over 3, correct. So let's put minus 1 in.
Into this. Right.
Into the 3x squared minus 2x minus 1. Yeah. So if you put minus 1 in, what do you get? What do you get on the left?
Okay, so 3x, so 3, 1, minus 1, squared, minus 2, minus 1, minus 1.
Okay, greater than 0. Okay, so now is that statement true? We need to check.
3 minus 1, squared, minus 2, minus 1. It's 4. 4 is greater than 0.
So it's true, good. So true is going to be written on the left of that, yeah, true. Okay, now we need to test the middle.
Sorry.
Okay. Test the middle. So what number is in between minus 1 over 3 and 1? Get any number, easy number.
0.
Yes. Okay, so let's put zeros in.
Minus 1. This is that's false.
Correct, good. Yeah, so it won't be there, that's false, correct. Now we need to test the other one. Any number bigger than 1?
So 2.
Fine, let's test 2. So if we put 2 in, what do we get?
That's true.
Correct, good. So what's the final answer? Final answer, so we need to put x's here. Let me use the pencil then. Okay, so what do? You write down an x here, you write down an x here, and then you put in the symbols. Okay, so what's the final answer? X less than minus 1 over 3. That's the one answer, and the other answer is x greater than 1. Do you see that? Okay, so you've done the test, you've done the hard parts. Now just write down the answer. X less than minus 1 over 3 or x greater than 1. Or x greater than 1. So those are the two options, and that's where the function is increasing. That's x less than 1.
The J said that
yes, but here the 1 is there and the x is there. Okay, so you can say 1 you can say 1 less than x, but we don't really write down things like that. Okay, so the 1, yeah, that around, okay. And that's it. Okay, so that's the increasing function. Do your practice exercises in that book, eh?
Yeah, in that book. Okay,
so I want to do one of these because this is something that's important, the fraction. So let's grab that book.
So this is when function increasing.
Yeah. Okay, so I'm going to give you a few of these just to practice what we just did here, because this is just the algebra. Okay, so let's just one. I'm going to give you one so you can see what to do, and then you can do all of them using what we just did here. Okay, because it's something that you needed to remember from last year. Okay. Alright, so you can put obviously you have some questions to do, which you can do either after it or before it, either or. But let's do one of these together, and then you can do the others on your own.
What chapter is this?
Chapter 5, it's inequalities. Okay, it's revision though. So, chapter 5, inequalities. Okay, so you can just label this 4A, number 4A. Okay, so your inequalities isn't a specific chapter in the work program that we need to cover, because this is stuff that you need to know, obviously. So it's not like here in the work program, but you can't do these functions without knowing this. Okay, that's why I need you to practice it. Okay, so number 4A, x squared plus 5x plus 6 greater than 0.
X squared?
X squared plus 5x plus 6 greater than 0. Right, the instructions for this whole activity is use any method you like to solve the following equation. So if I'm solving for x, that's what I'm doing, solve for x basically. Okay, so that's kind of what we did earlier. We were looking at the increasing decreasing function. We were just applying this to a specific area in maths. Okay, so this is just like solving. So let's solve for x. What do we do?
So,
yes, so factorize. Good. That's the first step.
Okay, and then we have, so we need factors of 6 and 5 to times 2 equal 5 and add 2 equal 6, so 1 and 5. Plus 1 plus 1 plus 5 plus 1. Yeah, 5 and 1.
Yes.
Plus. Because 5 times 1 is 5, and then 5 plus 1 is 6, so that's right. Okay, so then will be x.
Oh, no. 5 and 1. 5 and 1 will give you the middle term, it won't give you the end term.
Yeah, but to get the middle term, what do we do to get the middle term? Times these two, hey?
You times the inners and outers.
No, but do you remember with
Can I have a page there? Let me show
normal
you.
trinomials?
Yes, normal trinomials. Let's discuss this because this is...
We have to find the factors. We say factors of 5 and 6, and then we say what the factors are. And then we times these two to get this, and we add them to get this, don't we?
No, other way around. Okay.
So we add them to get that, and we times them to get that. Okay, that's what I wanted to do.
Okay, because why? If you FOIL it, how does FOIL work?
Okay, so you have to add these two to get that. So this plus this equals this, and this times this equals that.
Okay, so if you have to FOIL it, let's FOIL that. What is x plus 5 times x plus 1? If you have to FOIL it, it'll be x squared plus x plus 5x plus 5 times 1 is 5. Okay, see, we're not going to get 6 there.
Yeah.
Okay, so if you FOIL it, that's
I just got confused which one to plus and which one to times.
Okay, so if you get confused, then go back to FOIL. Okay, FOIL actually answers the question. If you have to, so you're just going backwards from the actual multiply out answer.
Okay, so then it would be, so you have to add these two to give me that. So that doesn't, so where are the factors?
No, what are factors of 6?
Factors of 6. 1, 6, 2, and 3. Okay, so it would be x 2 and x 3.
Okay.
So 2 plus 3 gives me 5, and 2 times plus 3 gives me 6.
Okay. All right. So that's the first step to factorize. Correct. Good.
2 minus 2, 4x equals 2 minus 3.
Is that the answer?
Yeah.
No, we need to do another step. Why? It's inequality. Exactly. Good. So just remember, with inequalities, we have to test. Okay, that's the whole trick with the inequalities. Okay, so you draw the number line and you do the test. So let's check what we get. Okay, so yeah, we did a test earlier. Let's see if you can do the test for this one. And what do you get?
Okay, so first we draw a number line. So minus 2 here, minus 3. Okay, so then solve. Any number below minus 2. Oh no, it's minus 3 minus 2. Minus 2. Okay, so any number below minus 3 would be minus 4. So now we test it with this. So for x squared plus 5x plus 6 equals 4. So we're testing for here, so minus 2 to minus 4. So minus 4 squared plus 5 minus 4 plus 6. That's right, eh? Minus 4 squared plus 5 minus 4 plus 6 minus 30.
Okay, so is minus 30 greater than 0?
Minus 30
False.
greater than 0.
False, so no, we can't have that.
4.
Can we grab one of these out?
False. So it can't be. Now test for the middle, so minus 3 minus 2 will be minus 1. So testing for the middle, minus 1 squared plus 5 minus 1 plus 6. So that minus 1 minus 1 0. Minus 2. 2 greater than 0. True.
Good, so the middle is possible, hey?
False.
Yeah, that's false, that's true, and then false. Well, test the last bit, but you'll see it's false.
True. Oh, wait. What's in between minus 3 and minus 2?
Minus 3 and minus 2, what did you have as the
I said
factors?
minus 1.
Minus 1, no, minus 2.5.
Okay, so I'm going to do that.
Okay, so, no, don't change it. Minus 1 is just that side,
Okay.
right? If you put minus 1 in. Okay, if I put minus 1 in,
So then that means this side is true then.
because those are positive, so
So now minus 2.5.
I'll just put a negative 2.5.
Minus a quarter. False.
Correct, okay, and then you'll have the final answer.
So it's false, false, true.
False, false. No, it can't be false, false, true. There's something wrong with one of them.
So yeah, for this side, I said minus 4, right? So minus 4 is a minus 3, so this is not going there.
Yeah, maybe check the minus 4 one then. Minus 4 squared is 16. 16 minus 20 plus 6. What does that give you?
2. Because you're wrong.
Okay, so just the substitution there wasn't right, okay. Right, so it was true, false, true. Then that's right. Okay. Okay, so I've given you 3 just to practice there for these, okay, just so we can get that right. because you do need it for this, the increasing and decreasing functions when you use the derivative. Okay. All right. So that's just one, just for us to discuss, just in terms of additional practice, just for the factorizing. I think the factorizing is the biggest thing that we need to practice. But once you get that right again, then it's good. Okay.
So then what would this statement be? It would be...
Well, yeah, just add your variables to this and then just solve. Okay, so put the x, then put the symbol.
Which is the
X will be less than is the other way around there. Less than minus 3. Okay, because think about it. If x is on this side, is x less than or bigger than minus 3? Exactly. And then here it will be minus 2 less than x. Okay, this I can write the other way around. Okay, so if I read it, I can write it down as minus 2 less than x, or I can write it down as x greater than minus 2. It's the same thing.
Sure.
Alright. Okay, so let's go back and just finish off this section.
Can I answer the bottom before?
Okay. There's a lot of applications for the derivative. Okay, perfect. So you've got minimum and maximum that you can find, as well as any points or stationary points. Okay, so now how do we do that? Yeah, that's the minimum. Why is it the minimum? Because it's the lowest point. Okay, it's the lowest point on the graph. That's the maximum because it's the highest point on the graph. And then those are just points that have a change. Okay, a change in the gradient. They call them stationary points. Yeah. Okay. But the most important ones would be the minimum and maximum.
Okay.
Okay, so this is the process, how we do it. Okay, so number one, step one, find the derivative. You always have to find the derivative because these are applications looking at the derivative. Okay, so once you've found the derivative, then you've got to make the derivative equal to 0. Okay, so step two.
Aren't we going to do it now?
Let's write down the steps and then you can do an example. Okay, there's a few more steps in this one. Step 2, derivative equals 0, solve for x. That's step 2.
And then step 3, solve for x.
No, derivative equals 0, solve for x. Okay, so, alright, then step 3, find second derivative. Okay, so remember earlier in the week we spoke about first derivative, second derivative, third derivative, so you can get other derivatives. Right, so step number 3, find the second derivative. And then step 4, test the second derivative for a max or a min. Test the second derivative for a max or a min. Okay, for a maximum or a minimum. And that's the process. Okay, happy with that? Great. Right, so let's have a look at an example, okay, where we are going to have to find the minimums and the maximums, okay, looking at a function. Okay, so here's the example function that we've got, e.g. Okay, so now we're going to apply those steps. The example is y equals x to the power 4 plus 4x to the power 3.
X to the power 4 plus?
Yeah, plus 4x to the power 3 minus 8x squared minus 7. Okay, that's the whole expression. Okay, so what is that? That's the function. What's step number 1?
Find the derivative.
Good, so let's see if you can do that.
Okay, so 4x.
Okay, so dy, your notation is important. dy over dx equals
4x to the 3.
Good.
Plus 12.
12.
X to the 2.
Good.
Minus 16.
16.
16x.
Good. You drop constants. Happy. Okay, so you've done step number 1. Right, what is step number 2?
This is number 1.
Yeah, what is step number 2?
derivative equals 0.
Good. Okay, so you need to find x value. See, solve for x. So make that derivative. You've got the derivative. Just write it down again and make it equal to 0.
So we just need to write this one in.
Yes, because you're only looking at the derivative. Yeah, so derivative equals 0, and then let's solve. Okay, so now some more factorizing practice. This is our basics. Right, be careful. When factorizing, what must you do? What's the first step with basic factorizing?
Take something out.
Take out common factors if you can take out common factors. Right, can I take out common factors?
Yeah,
besides x?
Oh yeah, so 2x.
2 possibly. 4 is better. Okay, so take out a 4.
We left with x squared plus 3x.
Okay, you can't take out. Okay, yeah, you're taking out. That's fine. Okay, that's okay. 3x what? Squared or? Well, you take out 1x, eh? So you're still left with.
Yeah, I'm still busy. Plus 3x minus 4.
Correct.
4.
Right,
okay.
Equals 0. Good. Okay, so now 4x.
Now we do it like this.
Trinomial, yes. Now you're factorizing that trinomial. Good.
So x is x.
Yes.
Okay, so now I need factors of 4 and 3 to add to give me 3 and to times to give me minus 4. So factors of 4.
Yeah, this I'll leave you to try to.
2 and 2. Okay, factors of 3 and 3. Okay, so everything is 1 and 3. 1 times 3 plus 3. That's what we can say minus 1 times 1 is 3. Minus 1 minus 3 is 3.
No, see, you're still doing it the wrong way around. Okay, you multiply to get the last. Okay, you add to get the middle.
Okay, so then it's 1 plus 3.
So look at the 4 actually, that's the more important number.
So that's 2 times to give me 4, eh?
Yeah, so 2 numbers that multiply that give you minus 4. And then those 2 numbers you need to be able to get a 3, a plus 3 with it.
Okay, so 1 and 4.
Yeah, 1 and 4 will work. Where is the minus, where is the plus?
Yeah. And then 1 plus. Yeah.
Okay, so what did you get?
Plus 1 minus 4.
Other way around. Okay, why? Because now you've got minus 4. Minus 4 plus 1 is what?
Yeah, but if you say 1 minus 4 plus minus 4 equals minus 3.
No.
Minus 3, okay? So
yeah, see? Okay, so minus 4 plus 1 is what? Minus 3, not plus 3.
Okay,
so that's the plus, that's the minus. So to change the signs.
Minus 4 plus 1. Perfect.
You wrote the same thing again, just the other way around. Change it to a plus 4. Okay, because look at this.
Yeah, I understand. Yeah? I'm just getting confused.
Okay, plus 4 minus 1. What is 4 minus 1?
3.
There we go.
Yeah,
okay,
I'm just getting confused. Okay, now what do we do?
Solve for x. So,
what about this 4x?
Okay, so x outside the brackets, what is x going to be equal to make the statement true? 0.
Okay.
Okay, so this x is 0. So x can be 0 or...
So
x can be 0 or what else? X can be minus 4 or x can be positive 1, correct? Okay, so now we've got all of them. Right, so now you've done step 1, you've done step 2. What is step 3?
Find second derivative.
Okay, so where is your first derivative?
Yeah.
Good. Take the first derivative and now derive that. So now you have to go d2x. Okay, notation is important. Okay, yeah, so first write down the first derivative. Okay, next line, d2y over d2x. Okay, that's the second derivative. The 2 just represents the second derivative, equals.
Okay,
so what is that?
3 times 4 is 12.
Good. 12.
X squared.
Good.
Plus 2 times 12 is 24.
Yes, correct.
Minus 16.
Yes. Okay, you drop the x if it's just got an x. There you go. Okay, so now you've done step 3. You've found the second derivative. Okay, that's step number 3. Now we need to test the second derivative. Right, so now what points do you have for x? 0, minus 4, and 1. Do you agree? Okay, so we have to use those points to test x, the second derivative. Okay, so step number 4 is the test. Right, so what are we going to do? You're going to take your 0, your minus 4. Yes, fine, thanks. Derivative, do you agree?
Yeah.
Okay, so point number 4 or step number 4 says we need to test the second derivative for the min or the max. Right, so now what values do we have for x? We've got this one, we've got that one, and we've got that one. So we've got 1, 2, 3 points that we need to test. Okay, and that's what you're doing in step number 4. Okay, so I don't know if you want to highlight that and use a different color. So what we're going to do here, testing the second derivative using the min or max requires you to substitute those points in.
Into, yeah.
No, into the second derivative, because you're testing the second derivative. Okay. Right, so let's put in the 0 first. If I substitute 0 into the second derivative, what do I get? Let's do that first. Yeah, maybe do that on a separate page. Okay, so 12 bracket 0 squared. Okay, you want to write it down, that's fine, yeah. Okay, so that is the second derivative, we're just substituting in.
Okay.
Perfect. Substitute 0 in. There's the first one. Right, so if I'm testing point 0, I need to substitute 0 in. Yeah, 0, minus 4, and 1. Okay, those were the 3 points we needed to test. Okay. Yeah, perfect. So we do the substitution and we get an answer.
0 squared is 0.
Correct. Anything times 0 is 0. So it's minus 16.
Okay.
Okay, because you would have a 0 plus a 0 minus 16.
Okay.
Alright, so now if it's a minus 16, is that negative or positive?
Negative.
Okay, so if it's a negative, it's a minimum.
Okay.
No, hold on. Minimum, negative, draw the sad face. Okay, so if it's negative, draw a sad face. Okay, there's the picture. So now that picture gives you what, a minimum or max? It gives you a max, yeah. So just be careful with that because it's the opposite. So if you get a negative 16, it's unhappy. Okay, unhappy means sad face. Sad face means we've got that picture. That picture represents a maximum. There you go. Yeah, so just be careful, that's the opposite. Right, great. So you've tested the 1 point, let's test the last 2. Okay, yeah, that you're going to have to plug in. That's quite a big one. What do we get? Now, just be careful with the substitution in the calculator. Try use brackets so the calculator knows how to do the bot maths. Okay.
Minus 160.
Minus 160, you substituted in. Minus 4. The answer here is 80. They've got 80 here.
12 bracket minus 4 plus 24 bracket minus 4 minus 16.
It's squared. It's, oh, no wonder you left out a square here.
Yeah.
There you go. Okay.
80.
Yeah, positive 80.
Yeah.
Right, so again we need to look at the picture. If it's positive 80, happy or sad? Happy. Okay, positive is good, so smiley face. Right, what does the smiley face give you? A minimum. Make sense? Okay. Last point to test. We've tested 0, we've tested 4, minus 4 rather. We need to test 1. What did you get? Perfect, 20. Okay, so what is 20? It's positive, again, a minimum. Yeah, smiley, that's right. Okay, 20 is positive, smiley face means minimum. Okay, so if we conclude, what would the conclusion be? Well, the question asked you to do what? Find minimum and maximums on that particular function. Okay, so let's just conclude. Okay, the conclusion. Therefore, we have a minimum at x equals 4 and x equals 1. That's what we found. Okay, we've got two minimums. Say we had two.
Minimum at x equals 4.
Yeah, for this one and that one. So we had a minimum at x equals 4, minus 4, and
1.
X equals 1, correct. Right, so there are two minimum points at that particular point.
Then we have a maximum.
Correct, and we have one maximum at point x equals 0. Right, so that's what you're doing. So you see, you're using a function, you're using derivatives, and you're getting information about the graph. Okay, that gives you the information relating to the graph, where you've got a minimum, where you've got a maximum, and what the graph actually looks like. Does that make sense? Okay. Right, then there's one other note here, just referencing problems. Okay, so minimum and maximums can also apply to story sums, okay, word sums. Okay, so I'm just going to reference.
Did we test? Was this testing? Hey?
Yes, step 4 was the testing the second derivative. Yeah, all of that you did there was the testing. That was all step 4. Okay. Alright, yeah, so the note here is minimum and maximums. It's still part of this, but it relates to word sums. So as a side note, okay, minimum, let's just say min slash max, or min and max, can apply to word sums or word problems.
Can apply to
word sums.
Problems.
Word problems, that's fine. Either or, doesn't matter. Okay. Example, e.g. volume, area, etc. Okay, the only two that I see here is volume and area. Right, they've given you one example here relating to a cylinder. Okay, so do you agree volume is what? A function.
Yeah.
Area is a function, length times breadth times height. Okay, that's volume. Area, length times breadth. So now if I know what the length and breadth is, I can find what the maximum volume is or what the minimum volume is. Does that make sense? Okay, so you can apply max and min to a specific topic. So for example, here's one. We don't have to do all the steps, but I just want to do the derivatives just to show that. Okay, because you can see it's a very long exercise showing what? Area, okay, which is something simple to understand. Okay, so on a separate page, let's just find the derivatives. Okay, I just want to practice derivatives because we can look at these when we do the assignments. Okay, we do the past papers. Okay, we'll cover more of those when we get there. Okay, so just as an example, right, we have, I'm going to have to sketch that just as a little sketch, just to show the diagram. Or you can just say cylinder, and then we can just write down the specs. Okay. Draw a circle and a circle. Perfect. Okay, so these are equations that we would have looked at previously in last year's maths module. Okay, where we looked at volume and area quite a bit. Okay, so what is the volume of the cylinder? Do you remember? Okay, well, do you agree it's a circle? Okay, and it's almost like many circles. Right, picture one circle and then another one on top, and then another one on top, and another one on top. Okay, so to find the volume, volume would be the area of a circle, which is what? Do you remember that? Pi r squared. Okay, and now if I've got one circle and I'm laying circles on circles on circles on circles to make a cylinder. Okay, so what must I do? Times it by the height. That's the volume. Okay, so now do you agree? If I wanted to find a minimum or maximum, what would I have to do? I would have to follow the steps. So step number one, derivative. Okay, so you'd have to find the derivative and then you'd have to work out the second derivative in order to find a min or a max. Okay, so let's just write down the steps. Step number one would be to substitute the given values in order to get an equation. Okay, once you've got the equation, then you can do the derivatives. Right, so
given values,
yeah, substitute the given values to get an equation. Okay, so once you've got the equation, then you can find the derivative. So point number two would be to find the first derivative. Point number three was second derivative, correct. And then point number four would be to test for a min or a max. Okay, just a note here, when looking at volume, can you have negative volume? No, you can't. Okay, so for example, in this example, what did we get? We had minus 4, we had 1, and we had 0. Do you agree? So let's assume that we had solved for x and we had x equals minus 4, 1, and 0. Can I have no volume? Can I have 0 volume? No. Can I have minus volume? No. Okay, so only positive answers will be used in application questions relating to this. Okay, that's just something to note, because yes, you will get negative values. It's possible, because when I factorizing can have positives and negatives. But I basically ignore the negative values because negative values don't make sense when looking at distance or volume or area or anything that is measurable. Okay, and that's something that you need to note here. Okay, you can just asterisk this. See page 49 work program. There is an example here. We'll do examples together when I cover the assignment with you and when we do past papers. Right, so this is just one example that you can reference. We'll do others when we get there. Okay. Right.